Director of Health Evidence Synthesis, Recommendations and Impact, HESRI, in the School of Public Health at the University of Adelaide. Head of Evidence Synthesis Taxonomy Initiative, ESCI, Founding Director of JBI Adelaide Grade Centre, past Chair of Guidelines International Network, GIN, and a National Health and Medical Research Council investigator. He's a systematic review, evidence implementation, and guideline development methodologist. And today he's going to talk to us about AI in evidence synthesis. So thank you very much for joining us today, Zach, and I'll hand over to you.
Wonderful. Thank you, Kieran, and thank you everyone for coming along today to hear this presentation. And it's wonderful to see some familiar faces in the attendees as well. So the topic of my talk is striving for efficient evidence synthesis and guideline development through the use of technology. So we'll touch on AI as well, but we'll also talk about automation more generally. We'll also talk about what software support tools are available that could potentially be used to support efficient evidence synthesis. And if we have time, we'll also discuss, I guess, some other strategies to make sure that you are conducting systematic reviews and guideline development as efficiently as possible. Now, that was a great introduction from Kieran, and I think he went through all of my roles, but just by means of disclosures of potential conflicts of interest, you can see some of my affiliations here. I do funding for systematic reviews and guidelines, and I do receive funding for that, but that goes to my institution, not to myself personally. And I am involved in many different methodology groups as well, and have a lot of different affiliations. I am funded by the National Health and Medical Research Council, who support a lot of my work. If you ever want to reach out, you can contact me on Twitter or through my email here as well. So just another disclaimer, which is particularly relevant for this presentation today. I was once upon a time a developer of a systematic review support tool or systematic review software called JBI Summary. I am no longer the developer or product owner for that software, which I'm quite happy about because it's not an easy job developing these sort of software programs. I'm also not an expert in AI or machine learning, but probably like many of you, I am very passionate about trying to make sure that my systematic reviews and guideline development projects are done as efficiently as possible. And that's the sort of angle I'm taking today with this presentation as well. So I don't know if I have all the answers. I don't know if I have any good answers for you, to be honest, but I hope we can have some good conversations, and I hope I can at least share our experiences with these sort of tools to obviously help you and your group. Okay, so this is what I'll try to touch on: evidence synthesis, past and present, automation and machine learning. What tools do people use, and why or why not do people use these tools? If there's time, I'd like to discuss this concept of the digital and trustworthy evidence ecosystem, which potentially could actually be a real game changer in the way that we produce and use evidence. And then I'll run through some of the actual workflows that we use here at HESRI to do our systematic reviews and guidelines. So let's just have a really brief recap on systematic reviews. So systematic reviews and evidence synthesis has really been around for over 100 years now, right back to the early 1900s when we first started to statistically combine the results of individual studies, through to, of course, the last 20 to 30 years when we've seen more modern systematic review approaches emerge, and the use of systematic support tools like RevMan, Summary, etc., which really started to come out in the late 90s and early 2000s. And we're at a stage now where people are using increasingly automation and machine learning in their systematic review process. So much so that in obviously the recent version of Prisma, it's now a requirement that you need to actually detail any reports or any methods that were used relating to automation in your process. And you can see that this term automation is mentioned a lot throughout the updated Prisma statement. So we can see that a lot of people are now starting to consider and more than consider, even use these automation tools in evidence synthesis. And really, it has exploded in the last 5 or so years. And AI in general is just also exploding and is becoming more prevalent, of course. Even so much so that there's now a Prisma extension for AI interventions in healthcare. So this isn't about using AI in your actual systematic review, but this is actually a Prisma extension looking at studies that are assessing or investigating AI interventions. And alongside that, we've seen that Cochrane have launched a new policy in AI as well. So it's very much at the forefront, really, of the evidence synthesis community, but really globally, the global community as well, the use of AI and how it's changing everything that we do in our day-to-day lives. One thing I just wanted to quickly mention as well when it comes to evidence synthesis is that there has been an explosion in methods for evidence synthesis as well. And increasingly, we are talking about this evidence synthesis family, where there are lots of different approaches now to actually synthesize the evidence, not just the traditional systematic review of interventions, but there are a lot of different approaches where really we now have methods to answer any question that could arise from the community or from decision makers using evidence synthesis methods. And we're getting more nuanced in our methods as well, and perhaps even more complex with our methodological advances, which are actually making systematic reviews and evidence synthesis projects even more difficult or specialized. And this can sometimes lead to the requirement for more specialist expertise, but also more time and resources to do reviews, which once again is promoting the use of AI and other methods to try to make this process more simpler or efficient. Now, you'll all be familiar with many of these challenges that we see in evidence synthesis, and the fact that there are just a lot of systematic reviews that are being done, but many of these don't really actually need to be done. Many of them are of poor quality or poorly reported, or the duplicate or redundant reviews, which have no subsequent impact on practice. And what we're really focusing on today, though, is the fact that a lot of these reviews are costly and time consuming, and a lot of them are out of date by the time they are completed, which is why we need to, or why we might consider AI and machine learning and other software tools and technologies to improve this process. I also wanted to touch on guidelines as well, but the development of guidelines has become more complex as well over the last 20 or so years. And it's increasingly sophisticated, the processes and methods that we need to apply in a guideline development process to meet international standards. And we know, and this is just an overview of some of the resources, checklists, guidance or manuals or standards that we need to adhere to or should be adhering to when it comes to guideline development. So as you can see, just like systematic reviews, guideline development as well is becoming increasingly complex. And just like systematic reviews, guidelines are costly and take a lot of time. There's a lot of person hours, and there's also a lot of duplication of effort and lack of collaboration and sharing, and some waste in the process as well. So what is a solution? Well, what has been proposed as a solution, or one of the solutions, is automation and machine learning. And you can barely go on Twitter or LinkedIn, or even perhaps open your email inbox nowadays without seeing some of these sorts of advertisements or tweets or posts about how AI can change your life when it comes to doing evidence synthesis or guideline development. And some of these tweets, let's say, or posts will make you believe that you really can do a systematic review at the push of a button, or at least within 10 to 15 minutes, with a combination of all of these different tools. And of course, with ChatGPT as well, can we just basically type into ChatGPT and ask it to do a systematic review for us? So really, everyone is getting bombarded with this sort of information. But what I would like to to just say straight up is a big warning about a lot of this. A lot of, I think a lot of these new tools that have been proposed to a more general audience, let's say, have a lot of issues in terms of their rigor, in terms of their development, and in terms of their trustworthiness as well, and in terms of what actual data is underpinning these models or tools that are informing any outputs as well. And it may be that a lot of these tools and processes that are proposed in these sorts of posts and tweets are incredibly useful for those who are just trying to do very, very simple literature reviews for a university assignment or to write a background or something like that. However, for us, for people like us, they simply do not pass the mark. Really, we want to create high quality, rigorous systematic reviews. And a lot of these tools, pathways and processes aren't going to really enable us to deliver something to the decision makers that we can have trust and confidence, and we know the results have some level of credibility. So there's no easy solution is what I'm trying to get at here. So let's talk a little bit more about perhaps some more credible options that we might consider in systematic reviews and guideline development. And I've been a part of a few studies now which have looked at basically the use of different tools to see what tools people are using and why they're using them, or why not they are using them as well. Because we do know that I was being slightly facetious before, but we do know that some of these tools can really improve the process and actually save us some time. So what tools are people actually using? So we've done a couple of surveys, and this actual study now was from 2021, which I guess is actually quite ancient in terms of systematic review automation. And one thing that I've found is it is increasingly difficult to keep up to date with all of the tools that are being proposed or being introduced to the market of evidence synthesis and literature review, and academia and research more generally as well. It is actually quite hard to keep up. When we did this survey, most people did say that these tools do actually save a lot of time. And in terms of accuracy as well, a lot of people said that these tools actually do increase the accuracy of the entire process as well. And that's often been a concern about using different systematic review software or tools. But we can see here that a lot of people actually think, at least the tools that we did a survey on, do improve accuracy. So what stops people from using these automation tools? And I think this is a really important consideration for any team or research group or organization that are starting to think about using automation tools or software in their process for developing evidence synthesis or guidelines. So you can see here that there are a lot of barriers to using these tools. And one is the learning curve. That a lot of these tools, some of these systematic review support software options are just too difficult to learn. There are time constraints as well in learning these. Some of the tools there is quite a large cost associated with them as well. For some people where English is not the native language, there is a language barrier to using some of these tools as well. Sometimes there's problems with accessing these tools and so on. In terms of guideline development, we did a similar survey as well, and once again, this article is slightly dated now. It was published in 2020. But you can see that there are a range of tools that were being used across the GIN membership. And the reasons that people were using these tools was really to be more efficient, to improve collaboration as well, and improve the quality of guidelines. And we can see that people use tools really throughout the whole process of the guideline development project. So let's talk more broadly now about automation. And one resource or one collaboration that I'd like to introduce you all to is ICESA, which is the International Collaboration for the Automation of Systematic Reviews. And they've put forward a number of principles for researchers who use automation or for people who develop tools to actually follow. Now, I think these principles are excellent, but the problem is we're not finding a lot of people are actually following all of these principles, particularly in terms of interoperability, in the ability to actually combine the use of different tools to create efficient pathways and processes. To improve collaboration between these groups. You know, it seems like there's a lot of competition in this space, and a lot of people, you know, are really racing to try to compete with each other rather than actually collaborating. And also a lot of these tools aren't always very transparent in terms of how they're developed, in terms of making code accessible, and what is obviously the models or the data underpinning the outputs of these tools as well. So it would be a great situation if more people were actually following these Vienna principles, but at least the ICESA group are striving forward to try to make sure that people do follow these principles. So what I'd like to move on to now is some more recent work that we've published about automation tools to support scoping reviews and what tools can be applied at every single step of a scoping review and how this can help improve efficiencies in this process as well. We categorized the tools that we evaluated based on these 4 levels, which basically where level 1 is really your standard systematic review management software or reference management software, which can help file management and just management of a whole process. Then level 2 tools, which really enable workflow prioritization, such as prioritization of relevant abstracts, so such as sorting abstracts when you're doing title and abstract screening based on the likely chance it will be relevant or included or meet your eligibility criteria. Level 3 tools are those that do perform a task automatically, but somewhat unreliably and require human supervision and training, and you can override these tools. And then level 4 tools, which eliminate the need for human participation altogether, other than giving instructions or prompts to the technology. So here is a list of tools organized by the scoping review step or task, which can potentially be used in the process of developing a scoping review. What you'll see here is that there are a lot of tools. Once again, there are a lot of different tools that you could use at the various steps. And I don't really want to necessarily recommend some of these tools over the other. I think what this just goes to show is that if you are interested in automation and machine learning, that you and your team need to really set some time aside to start to evaluate your workflows and processes and see how these different tools could potentially work for you based on the projects that you do, based on the timeframes that you have available to you, and the types of evidence synthesis approaches that you more commonly do as well. So I think that is one of the biggest implications from this work, that there are just so many tools out there, and really some sort of evaluation and then implementation process within a systematic review team or organization is really needed. Okay, but we're not the only ones who have done reviews on artificial intelligence and systematic review and guideline development support tools. In fact, there seems to be a bit of an explosion about people writing about this in the literature as well. And in fact, a lot of different groups have conducted scoping reviews or systematic reviews on AI and automation and its role in evidence synthesis. And perhaps one thing that we could do is actually collaborate in this space and develop some sort of living evidence synthesis on all of the different AI and automation tools and focus on evaluating the credibility of these tools and their outputs as well. But nevertheless, there are lots of different papers and articles that are starting to come out regarding different automation tools and the roles that they can play. This paper here, How to Optimize the Systematic Review Process Using AI Tools, seems to be one of the more recent papers that has come out. And similar to our work, they basically talked about the different tools that you could use based on the different steps of the evidence synthesis process. Once again, it doesn't necessarily recommend a workflow for teams to follow, but just provides a long list of tools that could be considered at the various stages. So once again, it really comes down to the organizational systematic review team to try to find out what is the best workflow for them and how they can integrate these tools into their workflow. Okay. Another report that was done, which also included surveys, was done by the European Centres for Disease Prevention and Control, and they looked at the use of and impact of new technologies for evidence synthesis. But really, the conclusions were that there weren't a lot of people using a lot of these tools due to the challenges and obstacles that do arise when using automation, including the training and the time to become familiar with these tools, the fact a lot of these tools aren't interoperable, the fact there are some costs associated with some of these tools, and that some of the tools just aren't fit for purpose as well. And here is just some more work which is going on from the Agency for Healthcare Research and Quality, from the Effective Healthcare Program. We've put forward a proposal or protocol to look at tools to automate or semi-automate evidence synthesis as well, and how these actual tools perform. So I'll be keeping an eye on the results of this review as well. Now, the other thing that I might mention is you're all probably being bombarded in your inbox as well from these tool developers who would like you to start using their tools. And some of you may have been contacted to actually be part of an early pilot, or to provide feedback, or to help these tool developers do their work. And what I've been finding is I've been getting contacted by a lot of these different groups, and they all sound fantastic. A lot of these new tools that are using, things like ChatGPT to assist in the systematic review process. The problem is that when you actually do go in and have a look, you see that there is some really great potential to a lot of these tools, but they just wouldn't fit your workflow. And there are some really serious issues, and they might not adhere to all of the steps that you need to follow in the systematic review process. They may not be able to include articles from all databases. For example, they might just harvest data from PubMed, and then you can only use data from PubMed rather than importing, an RIS file of your full searches across published and unpublished resources, and these sorts of things. Some of them are doing really, really novel or using really novel approaches in the way they have designed these tools. For example, in terms of accessing inclusion for a full text article, instead of just asking, ChatGPT and saying, this is my eligibility criteria, do you think that we should include this study in my systematic review, and then asking ChatGPT to give you an answer. Some people have created these ChatGPT bots where you have one bot which is arguing for the inclusion of that article, and another bot which is arguing for that article to not be included, and then a third bot is then making that judgment based on the actual arguments put forward by those two debating bots. So really, really interesting techniques, but once again, at this stage, I haven't found any of these to really fit workflows. And and if I can just moan and groan for a little bit, it feels like a bit of a waste of time when you are really evaluating a lot of these tools and trying to see if they work, and then realizing actually they aren't working too well in your process. Okay, sorry, there's just a couple. So where does this leave us? Well, there's a lot of hype, but I'm really not sure all of these different applications really stack up or can actually be used with any trust, with any certainty, and even to truly save you much time. At least a lot of the ones that I've just shown. Everyone's really looking for an easy answer, and I don't think one exists yet. Certainly not a perfect solution exists yet. And so what we've found is we've had to use different or a combination of tools, depending on the type of project that we're doing, and then develop these different workflows and processes, which try to make the best of these tools to fit what our particular project. So I don't think there is an easy answer, and apologies if you're looking for a recommendation about how you could just use one tool to do it all for you. Personally, I have a lot more trust because there has just been this explosion, and there seems to be so many groups and people putting out different tools. I have a lot more trust in what I would call credible and evidence synthesis specialist organizations or collaboratives who are putting out tools such as Covenants, EpiReviewer, iCESar, the SR Accelerator from Bond University and the Institute of Evidence-Based Healthcare, Magic App, and GradePro. And I know these teams have people who are evidence synthesis or guideline development methodologists who actually really understand the process of systematic review and evidence synthesis and what is actually required to produce a high quality systematic review or guideline. A lot of the groups who I've been talking to or would like me to help them with their launch of their tool or to test their tool, they show a lot of enthusiasm and may bring a lot of good technical know-how, but they don't bring that evidence synthesis methodologist expertise, and that when you actually try to use the tools, you just find out that the workflow or process breaks down. Whereas, as we know, using tools like Covenants and EpiReviewer and SR Accelerator and Magic App and GradePro can certainly help improve efficiencies in systematic review and guideline development, and they fit with workflows, or at least this is what I've found. The other thing is that these tools are less likely to disappear, and I think they're more likely to be maintained. They have good reputations, have been around for a while now. I think some of the problems with some of these other tools is that they're a bit of a flash in the pan, if I can say that, or they look good, but they'll probably disappear. The other problem with some tools, such as some of the shiny apps that you see being pushed out, is that they look really good once again, but then they aren't actually maintained, and there can be some bugs, and then it's hard to find the developers, or the developers lost funding, and that tool is no longer being maintained. So what I'm saying, what I've found with a lot of these tools that I prefer to use, at least, is that they do make improvements. They do save time. They save hours, and they do make the process more efficient. But they aren't necessarily a game changer. They don't really revolutionize the whole evidence synthesis and guideline development process. In that, it doesn't mean you can do a review or a guideline, in a day. As compared to how long it would normally take. One of the reports, which I think is really, really useful, that has come out recently, doesn't necessarily focus on what tools should be used or what tools exist or an evaluation of the tools, but it actually goes into how you should consider implementing machine learning in an evidence synthesis group, and some of the challenges that the Norwegian Institute of Public Health actually faced, and how they tried to overcome these challenges, and how they implemented these tools within their group. And it's a really, I think, realistic view of what it's like to use machine learning and evidence synthesis, and what it's like to actually move from a workflow and process where you're not using these sort of tools to one where you are starting to use these sort of tools. And I would recommend that you do have a look at this report if you are considering implementing machine learning within your organization as well. and they provide a lot of tips and tricks and take-home messages along the way. The other thing that I would recommend if you are considering, once again, using these tools is to take a look, and although it's a little bit outdated now, look at some of the facilitators and barriers that have been reported in the literature about using these tools. And although this is sometimes perhaps more useful for the actual tool developers themselves, I think it can also help those who want to implement the use of new tools within their organisation. So I did mention some of my preferred tools previously, and one tool that I just wanted to highlight is Epi Reviewer. Now, I'm not sure if many of you have used Epi Reviewer in the past. We certainly do use Epi Reviewer. We particularly use it when we are developing evidence and gap maps and scoping reviews. And we've found it to be a very powerful tool. It has a lot of functionality. It also has a lot of flexibility and the ability to modify and tailor it to your particular project. But we've also found that there has been a really steep learning curve. And in fact, the first couple of times we used it, we found it just incredibly confusing, I have to say. But that learning curve has paid off. And now we always use Epi Reviewer when we are doing evidence and gap maps or mapping reviews. And Epi Reviewer has been, and James Thomas, who leads a lot of this work, they've been working on automation and machine learning for many, many, many years. And once again, these are people who are methodologists and understand what a rigorous evidence synthesis project needs to look like. And they've really do their homework and make sure that any machine learning or automation functions that they introduce are really tried and true and tested, and that they also provide, guidance and any caveats to the use of these tools as well. So that I just thought I'd mention Epi Reviewer there, who are a group who have been doing it for a long time. Okay, all right. So what could be a game changer is actually rethinking the whole evidence ecosystem. And this term, the evidence ecosystem, is a term that's used to describe the flow of evidence, basically through the ecosystem of evidence-informed decision-making, or even through, say, health systems, healthcare, clinical practice, and public health as well. And what we can say, and a lot of this work has come from Per Oliver Van Wyk and colleagues working at MagicApp. And also some of the concepts I'll present in this very short section come from the GIN Tech Working Group, the Guidelines International Tech Working Group, and the work of Brian Harper at the Health Evidence Knowledge Accelerator as well. So when we think about our current evidence ecosystem, we can see that there is a lot of data produced at the various stages of this evidence ecosystem, from how trials and primary research is conducted, and the data formats or the actual outputs and results of that data, and then how that moves through to people who are doing the evidence synthesis and guideline development, and how the actual data from those primary research moves to evidence synthesis. And unfortunately, a lot of this time it's from PDFs, which aren't machine readable. It's not necessarily structured data. It's not interoperable or easily harvested, and these sorts of things. Then we need to move from that evidence synthesis to disseminators and the clinicians, through to the informed and shared decision-making process between clinicians and patients or the public, through to actually implementing evidence, including clinical decision support and electronic health records, and then improving, evaluating this evidence, registry type data as well, through to, once again, conducting that primary research. And the problem we have is that the flow of evidence is incredibly inefficient in this system. Once again, a lot of the time we're using unstructured data, which requires a human to actually highlight or extract or select data before it can move through to the next stage, and then we put it in a particular format which is incompatible with the next system which is used down the line. So GIN Tech, as I mentioned, has been discussing this for a very long time. and how we can actually improve this and make it better. And one person who actually really really drove this forward is Brian Alper. And sorry, my slides have just gone a little bit strange. Who's really grabbed this bull by the horns and is trying to create a standards and for healthcare information in our space and evidence synthesis and guideline development, and to try to make sure that evidence can actually move more freely across this evidence ecosystem. And he likens this to this concept to how location knowledge has evolved over time from pure print to moving through digital formats. So, you know, a PDF that's electric, or a PDF which can be on a digital disc, a CD, from executable, where you can actually start to plan trips, to computable knowledge, where, you know, it's really interoperable through different applications and processes. It's living, so to speak, and that you can get up-to-date guidance on traffic and whatnot. So if biomedical evidence was computable like location knowledge, we would be much closer to having a very much more efficient digital and trustworthy evidence ecosystem. And to do that, we need a standard. What is a standard? Well, you can think of shipping containers, which are obviously follow a standard, an international standard now. Before shipping containers, you know, we had people transporting cargo in sacks, in barrels, through, and then we started to see some early shipping containers, but still they were of different size and structures, to the first container ships and modern day container ships, which are also tagged with the relevant bit code, which has made, you know, shipping and moving cargo more easy at a grand scale. And what's called FIRE helps solve some of this by implementing this standard. And this group are trying to, Evidence-Based Medicine on FIRE and Health Evidence Knowledge Accelerator are trying to create this standard. And you can envisage a world where one day, and this is a busy slide, but one day when you have all of your clinical trial data in a structured format, including effect estimates, which have been tagged to a particular ontology, the risk of bias of that, of all of those effect estimates, the certainty, all of these things, where you could then actually truly automate, say, a meta-analysis and a systematic review board, and even perhaps an assessment of certainty using grade at the push of a button, because we have tagged all of the important data using this standard, which is allows this interoperability throughout the whole evidence ecosystem, which would result in what we might call this digital and trustworthy evidence ecosystem. And this could be a true game changer in this space. Okay, there are other solutions as well, and I talked about processes to develop efficient systematic reviews. And one thing I just wanted to highlight is it's not all about the technology, it's also about the people processes as well. And a really nice initiative is a 2-week systematic review, which has combined people and processes along with the technology to create trustworthy, high quality, rigorous systematic reviews, which can be done in a short time frame without losing any rigor. And this is done through dedicated time, through using specialist teams, through having constant meetings, working together, and then of course using the technology as well. So it's not all about technology. We always need to think about the people and processes as well. And one thing I just want to highlight is that sometimes a solution to some of these challenges we see with timeliness of systematic reviews is to do a rapid review where we start to retreat from systematic approaches or rigorous approaches and do slapdash efforts. And in my mind, some of the rapid reviews that we see that get put out there are perhaps have as many issues as if you would use AI or some of the AI tools that I mentioned much earlier on without any validation. And then the final results are potentially not very trustworthy as well. So it's much better to try to think about people, processes, and technology to do high quality, rigorous systematic reviews rather than trying to take shortcuts to abbreviate the process. Okay, I can see that we're running out of time, so I might whip through this. But another thing that we can do is create evidence maps. So if you have an evidence map for a whole condition or a disease area where you are indexing and keeping this living with all new evidence that is emerging, then it's a lot easier, I think, to then, for many different groups, to actually then pull out components of that and conduct relevant targeted systematic reviews in that disease area. And we saw this start to work in COVID-19. And another thing that we saw is, these study registers where people have, or machines have actually tagged all studies that are emerging in a particular disease or condition, so that instead of having to do systematic searching for every single evidence synthesis process, you can rely on these study registers or comprehensive evidence maps to inform your systematic review, which could save you a lot of time if we had these global assets or global goods, these evidence maps or study registers in all of these spaces. And another great initiative, which many of you may have heard about, was a COVID network meta-analysis initiative, which did a living map, but alongside that did a living synthesis, and was just incredibly impressive what was achieved through this initiative. The ALIVE, or Alliance for Living Evidence, is trying to make this the norm, where we have these living evidence data sets or global goods, which can then be shared across the international evidence community. And then contextualized to particular jurisdictions in terms of guideline development and HTA. So that is what this ALIVE group are trying to achieve. And of course, we can always build on the work of others, and we're seeing recommendation maps starting to emerge in different areas, which help facilitate the process of grade adolament, which is the process of adapting or adopting other people's guidelines and recommendations to your own setting or jurisdiction. Okay. I'm just going to skip through this, which was an example of a project where we did an evidence map and overview of reviews to be more efficient. So I'm just going to touch on some of our workflows. So after all of this, what do I actually do, or what does my group actually do when we do systematic reviews? Well, for systematic reviews of randomized controlled trials, to develop the protocol, we use previous templates. We have used a summary in the past as well, which produces tailored templates depending on your systematic review question or type. Our review manager, of course, as well, or the methods wizard from Bond University, which is a very nifty tool. In terms of searching, we use a polyglot search translator to translate search data, search strings across different databases, from Medline to Embase, for example. We use SpiderSite for forwards and backwards citation searching. CoSites we've used a couple of times as well to identify seminal articles in the field. We use the deduplicator process or tool from Bond University as well, and we still use EndNote. For screening for RCTs, we use Covenants, and we use the RCT classifier now when we aren't just including RCTs. And we also use Covenants for extraction risk of bias. Analysis, we use RevMan, and the write-up Word and EndNote, and then searching and findings, we use GradePro. For scoping, review, and evidence maps, we use templates from Summary or templates that we've had previously. Searching is very similar. For screening, we'll either use Covenants or EpiReviewer. Sometimes we'll use Covenants at a title and abstract stage because we just really like the interface, and then jump into EpiReviewer for full text, where we start to do some of the coding for items in the map so that we're doing full text screening and preliminary coding at the same time. Extraction may be in Covenants or EpiReviewer as well. There's no risk of bias. And then we do our analysis using EpiReviewer. We generate our map using EpiMapper, and some of our presentation of data, including crosstabs and etc., we can use EpiVisualizer, which is a nifty tool once again, which provides tables and other things based on the what you put in EpiReviewer. And sometimes we use NVPerf as qualitative data as well. For guidelines, it's very much the same, but we We also use Magic App, which can help facilitate the living mode. We also have used Grade Pro to help do panel voting, to do reviewing of recommendations, etc. To automatically generate shared decision-making tools, you can do this in Grade Pro and Magic App as well. What about ChatGPT? Can we use ChatGPT in systematic reviews? This article looked at ChatGPT just for searching, and they found that more research is required, and currently limitations outweigh the strengths of ChatGPT for searching. How could we use it though? And I've been involved in some studies which looked at how we could use ChatGPT and Claude, which is another generative AI tool. Perhaps you could use it for background and discussion ideas. For guidelines and other projects, you could also, it also provides some nice suggestions for risk management or project management plans as well, and considerations. It could perhaps provide you some suggested text for method sections, particularly for guideline protocols. It could do a risk of bias or critical appraisal on individual studies, but I wouldn't consider this trustworthy, but it might give you some ideas or some suggestions about what to look at. I've done some very preliminary testing in Claude for risk of bias, and I must say it was quite impressive what it could do. Still not fully trustworthy, I wouldn't say, but quite impressive. Potentially useful in search term generation. ChatGPT can also be used to generate code for R and potentially other programs as well. I haven't used this in evidence synthesis, but I have used ChatGPT to troubleshoot R code for other types of research, and to even suggest R code as well, which has really worked. But no, don't take my word for it. Do your own evaluation, of course. And there's been some work looking at ChatGPT for plain language summaries and executives summaries as well. One thing I think is worthwhile to mention, though, is that ChatGPT has been consistently evaluated throughout its various versions in terms of its usefulness for evidence synthesis, and it seems to be getting better. And I've noticed that myself with versions. I remember asking ChatGPT when it was first released to give me a list of publications written by Zachary Munn. That probably sounds a bit big-headed, but half the publications were hallucinations. They sounded like papers that I would have written, but actually never did. I just asked it again today to do the same, and it actually gave me a list of true publications. So it is improving a lot, and who knows what it will be able to do in the future. But at the moment, I think there is some hesitation. And this hesitation was also discussed in this paper here, where I was one of the participants in this survey, and which really mirrors what I've just presented. Okay, so some concluding thoughts. No single software solution is perfect yet. When you are considering AI and machine learning, consider the actual evidence synthesis type you are doing, the scope and restrictions as well. Consider people and processes, and not just the technology, and how you're going to implement any technology. Consider, obviously, whether or not these tools have been developed, particularly these large language models, based on all knowledge, and think about the credibility of the outputs that are being spat out by these tools. There is a need for investment in training and upskilling when you start to use these tools, particularly tools like Epi Reviewer, which I would say the investment in training and upskilling is worth it. Think about your different workflows for different projects, test these workflows, and continually refine these workflows as well. And one thing we always do is have a debrief after every single project that we do to think about how we could do things more efficiently as well. And obviously, don't just put all your eggs in a basket of AI and machine learning. Consider other approaches to improve efficiency as well, such as by doing living reviews or living guidelines, using evidence maps, using a document, or updating and adopting work of other people. And it is starting to be easier to update our work based on the work of others, as we start to see the principles of open science be taken up. So we've come a very long way. I still remember having to go to the library and actually looking at journals, issues of journals, to find the articles, and then photocopying them when I first started in this field. and only using, manual referencing and making decisions on inclusion by writing yes on a printed out piece of paper. And there was, once upon a time, no interoperability. So we have come a long way with a lot of these tools, but we still have a long way to go. If you're interested and you're coming to the Global Evidence Summit, we are doing a workshop on the principles for the use of AI and machine learning and evidence synthesis. And it'll be great to see you there as we discuss a lot of these issues amongst the community at the Global Evidence Summit. And I really do hope to see you all there. But I better stop now because there's probably some questions and I think I've gone over time, but I would love to hear your thoughts and reflections.
Thank you, Zach, for a fascinating talk. I think I learned so much there, but I'm going to open up to the floor. I'm sure people have loads of questions. We have about 8 minutes. So just raise your hand if you have a question and just shout. I might just get the question started anyway, Zach. I suppose it's just kind of a, in 5 years' time, where are we going to be with automation? Do you think everything will be, I'd say, level 4, level 3? Do you think there's so much unknown? Do you think there'll be pushback? Where do you think we're going?
Yeah, I think it's hard to say. I don't have a crystal ball. I think there are iterative improvements, and we're seeing improvements year by year by year. Will you ever be able to do it at the push of a button? I guess some of it depends on the success of this HEVCA project I mentioned, because I think that could be truly game changing, where we really can reuse assessments and data by other people, so that only one person or one group ever would need to do a risk of bias or extract the results of a trial, and then all of a sudden it could be used in so many different ways across the evidence ecosystem. If we succeed in that initiative, and I'm not sure, to be honest, I'm not sure we will, due to there's so many structural barriers, that could be a huge game changer. In terms of the ongoing development of AI and different tools, they will continue to develop. Covenants have big plans, and I would consider Covenants a really trustworthy tool, and I expect they would continue to make advancements with extraction and risk of bias assessment and everything else. So,
cool. Thanks, Zach. Yeah, so we use Covenants. That's our mainstay. So, Barbara, I'll go to you first.
Thanks, Zach. There's so much there. My mind is swirling, so it was brilliant. Thank you. But I suppose just thinking from a practicality point, with you and the team, how do you kind of monitor this? Is this because you're so well connected with all the different groups and you know what the new advances are and which new tools you might consider as part of your process? Or is someone in your team kind of monitoring this closely and saying, hey, this tool has had some changes, I think we should revisit it? Or what way do you guys approach that?
Yeah, it's a good question. How do you keep up to date? And to be honest, Barbara, I'm finding it harder and harder to keep up to date because there are so many tools. I am a part of a number of working groups, so GenTech working group, the Grade Tech working group as well, and ICESA, which helps me keep up to date. But I also, I try to keep an eye on what's happening. How else do you keep up to date? One incredibly useful tool is a systematic review toolbox, which indexes these tools, but it's been down since April, which is a real shame. And I'm not sure, I really hope it's coming back, because that is a great resource where you can actually, that does keep up to date with all of the different tools. But it is hard because there's been this explosion of tools, and you start trying one and realize it doesn't work, and then another one comes on the market and you try to test it out. So you might have seen I was starting to get a little bit disillusioned with some of these new tools, and I'm starting to just try to rely on what I consider the more reliable ones.
Thanks, Barbara.
And just one final thing, and it's not necessarily, it's more of a comment than a question, that annoying thing. I think, with your talk as well in the Global Evidence Summit, I think some of the principles that we need to think about really come back to some of the sustainability around all of this yesterday. So there was a lot in the news in Ireland yesterday about our data processing centres are using more electricity than any home, all of our homes put together. And I think there is a kind of sustainability angle to all of this in terms of how we're using it as well. Just something I think we need to think about when we're thinking about principles generally.
Thanks, Barbara. I've taken a note there. There's also I also didn't touch on the ethical implications of AI, but there are a lot as well.
Thanks, Barbara. Barry?
Thanks, Kieran. Good evening, Zach.
Hi, Barry. Good to see you.
Good to see you. I think your warning at the very start was quite good. Basically, you're saying that kind of from a reviewer's point of view, that there are kind of bells being rung at the moment. My question there is around the work Barbara was doing. She looked and did a very nice bit of work and look at decision makers and how they use our kind of evidence summaries. And one of the things is that they're not really too interested in the methods section. So with that in mind, how do you think like our business is evidence informed decision making? So do you think maybe not this year, but in the future, that decision makers will be crying out for these fast tools? So rather than like focusing as we are, like we're focusing very much on the using citation tools like covenants and stuff at the early stages, and maybe kind of looking at classifiers as well as screening. So that's low risk machine learning. But would the decision makers want to push us? So using generative AI to do risk of bias and basically making decisions by pressing buttons.
I'm very worried about that, Barry, or completely bypassing, people with these sorts of skill sets, completely, by just using these sort of tools themselves to give them the answers. As we know, they are prone to provide unreliable information. And when comparing outputs of ChatGPT to, say, Cochrane reviews, we find that ChatGPT falls a long way off the mark. So I am very worried about this. I'm worried about funding for evidence synthesis more generally as well, and the increasingly push or demand for decision makers for more, but with less funds, which is really, really hard. So yeah, this is something I'm worried about. I think we really need to keep working and engaging with decision makers, policy makers, etc., about the importance of rigorous evidence synthesis, some of the issues with some of these tools, and the actual realistic expectations of how long some of these projects do take, even when you are using reliable tools.
That's the thing. When will somebody actually read the study, the original primary study?
Yeah.
I have a small bit of thing to add there. You mentioned about there's lots of scoping reviews going on, and this is something we spoke about in our working group, Kieran and Marie and myself, is around that there are great scoping reviews going on. Would there be an opportunity? You mentioned collaboration. Like as these scoping reviews are updated, would it be an opportunity to actually test out the citation tools? Citation searching tools, so you could actually do it remotely, side-by-side comparisons, where one team would use one type of tool, another team would use another, and then compare the results in terms of accuracy and usability.
Oh, definitely. And the SWA program, the study within a review program, I think is I think a lot of these ideas about testing different tools and processes and workflows would be ideal for sort of doing these actual empirical studies of different tools and processes within a systematic review.
Yeah, great. Thanks, Barry.
Send you an email and offer myself.
Volunteer. I just noticed we're at 11. Do you have time for one more question, Zach, or do you have to leave?
No, it's 7:30 at night, so I don't have any other meetings after
this. Okay, great.
Well, I do actually, but not till 9:30.
Okay. Oh wow. Okay. Look, thanks very much, Connor. Do you have a question there?
Yeah. So just two things. First of all, the concept of reproducible research, and how does that fit with these sort of AI and machine learning technologies that are constantly evolving? So if you produce a systematic view today that uses certain versions of the software out there, in 6 months' time, you might get a very different answer using the exact same recipe. Does that worry you?
Yeah, so there's been studies looking at reproducibility and replicability of reviews and the reviews that are used in guidelines. In fact, we just was fortunate enough to win a grant from CIHR looking at these issues, the reproducibility of reviews which have been used in guidelines. So when we talk about reproducibility, that's talking about things like having really open and transparent processes. It's about having open code. It's about sharing all of the data, all of these sorts of things, so that you could actually reproduce the findings because they have provided, the code and very, very clear detail about it all. Are a lot of reviews reproducible at the moment? Well, there's a lot of issues, really. With this, there's huge issues, but once again, I think I mentioned it. We, very slowly we are moving to more open science, and also achieving this principle of open synthesis as well. But it's certainly taking time. Does that answer your question, Connor, or is that?
Well, I was thinking myself anyway. Surely the biggest barrier to reproducibility is the human element anyway. So the sort of the critical appraisal bit and the interpretation, all that can be quite subjective, and that's probably the bigger part rather than the identification of studies.
Yeah. So sorry. So there's reproducibility, and then whether or not things are replicable as well. So getting the results, and they're related but slightly different concepts. So there could very well be issues where I do a risk of bias assessment and say, have you heard of a systematic review data repository, SRDR?
Yep.
So SRDR, they actually have all of the risk of bias or critical appraisals and the results, etc. So that theoretically other people who are doing a review, which also includes a study which was in a different review, they could just pick up those risk of bias assessments and include them in their study. Now that requires a culture of trust and of willingness to share, and making which I don't think we always have that culture in research, to be honest. And a lot of people like to do things from scratch.
The only other thing I was interested in then is if people move more and more towards AI as a means of identifying papers, that will push certain authors to tailor abstracts and titles and things so that they're more readily picked up by AI, so that they basically learn how to shout loud and be seen. And that would be a worry, obviously, that industry might tailor papers and that academics may not, so that the less biased research may become less obvious. I don't know if you've thought about that at all, or concerned yourself at all at this point.
Not necessarily with, I think that the savvy researcher, as dare I say it, will try to create titles or put information in the abstract, which will mean it's more likely to be identified through the use of keywords, but not only that, through relevant searching and just Google, etc. I think that's an interesting issue which I haven't really considered about, but obviously we have things like reporting standards like Prisma for abstracts, which hopefully would detail the key elements. There are pushes against spin as well. There's evaluations of spin in abstracts, and it's been found that it's very, very high and very poor. Currently, this is pre-AI, but that's an interesting concept. I haven't really thought about that too much.
Great. Okay, thanks, Connor. Is there any concluding thoughts from anyone? Does anyone else want to say anything or ask Zach a question? Or no? Okay. Maureen, do you want to come in?
Yeah, just to say hi, Zach. We haven't actually met in person, but as you very kindly have supported us with our recent grant application, and it's really lovely to see you in person, and I hope to meet you in person soon. And thank you so much. Thank you so much for that that overview. It's been really really interesting, and I think it's probably going to spark a lot of thinking for us, and probably a lot of action on our part as well to move forward with this. So there's a number of the team going to the Global Evidence Summit, so I'm sure they'll be hoping to connect with you there. So thanks very much.
Yeah,
wonderful. Well, if you are at the Global Evidence Summit and you see me, come say hello. I'd love to have a chat.
Great. Yeah. Okay, well, just to conclude, thank you very much, Zach, for taking time out of your evening to speak to us. We'll be in touch with the Slicer grant, and I'm sure you'll see some of our colleagues at the Global Evidence Summit. So thanks very much, Zach. And
thanks, everyone. Thank you. Bye.
Cheers, Zach.
Thanks, Zach.